Hey guys, Coco back again with part 2 of how to build a computer inside of Minecraft with Redstone. In the last episode, I left you with this kind of very simple 2 register setup for like a 2-bit quote-unquote computer with a very simple controller right here that'll just move whatever's in register A into register B. It'll copy A to B. So let's go ahead and input some new data into register A just so I can prove to you that this is working. So in register A we have the number 3 notated by 1 1, and in register B we have 1 0, so the number 1. So we have the number 3 and the number 1. So this button right here, what it does is it's going to manipulate these registers and control blocks in such a way to copy what's in register A to register B. So let's go ahead and watch that happen. And bam, you can see that we now have the number 3 inside of register B. If you don't know how this is done or how this happens, go ahead and watch episode 1, and you can see me explaining all of these registers and control blocks and buses and what they all do and their function, as well as this blue cyan line of how it controls and makes sure that A gets copied into B. In this episode, I will be taking this blue line out, and I will be replacing it with something a little bit more robust and a little bit cleaner looking, so that way we can have a better controller for our quote-unquote computer here for us to expand into. So that's what I'm going to be working on today. So let me get this out of here real quick, and then I'll show you exactly how we're going to implement making this a more robust system. So I'm going to go ahead and remove all these buttons as well. For all of these things, I do still need a line that has a torch on it for these. Coincidentally, I just reset my registers on accident, but that's okay. And now I'm going to use, instead of this cyan color, I'm going to use gray, just because that's what I'm used to using for my control lines. You can see my project in the background, there's quite a bit of control lines going on for that. So we're going to wire all these control lines out here over on this side, so that way we can build a better controller for our system. And I'm going to show you how I do it. One, because it's the only way that I know, and also it's kind of the most efficient way that I've found of doing it. So if you guys have a better way of doing it, please comment down below. Maybe reference your own work or anything. I'd love to see what you guys got going on down there. But this is going to be a really simple way, and hopefully I have a decent way of explaining exactly how this works. So I'm going to start by doing a little time lapse of me wiring all of these control lines where we used to have buttons that controlled all this stuff out to like a single array of just like this button does this, this button does this, this button does this, this button does this. So we have everything kind of centralized over here for a controller. So I'm going to go ahead and do that, and I'll see you guys in just a minute. Awesome, so welcome back, and I've wired up all these control lines, so now you can see that what we have, oh, I forgot to remove these, is instead of having to go around and hit buttons or all those cyan button or that cyan line, now we have all of the buttons that we have at our disposal right here. So you can see that if I, being the controller of the computer, can pretty much perform all the functions that this computer can do by hitting these buttons in the correct order. So let's go ahead and do the same thing that we've done before. So let's input 1, or I guess let's do it over here. So in order to input into the A register, I follow this line. So this is going to be the A register. So I've inputted into the A register. And then I want to take what's in the A register and I want to move it back out to the input register. First I want to clear the input register. And then I want to take what's coming out of the A register into the input register. And then I want to clear whatever's in the B register, which is this line right here. It's already empty, but just for operation's sake. And then I want to take whatever's in the input register and put it into the B register. So now you can see we've performed exactly the same function by copying 1 from A to B, except for now we've all done it from those buttons over there. So it does exactly the same thing, but we've actually lost functionality because we don't have that blue cyan line that's doing it all for us. But now we have everything in a central place that'll let us do it. So let's go ahead and extend these out just a little bit, and then we're going to run a blue cyan line that's going to control all of this for us, and you're going to see exactly how we're going to do that. So let's say that this is the only functionality that we have in our computer. So we're gonna want to run some type of line across them that's going to perform all of these functions, and then we're going to have to find some way of ordering these functions in a different, like one order or another. This is where I put my torches, so this is where I'm going to put repeaters, so that way I'm sure that all those connections can reach. So we're going to run some line across, and all we have to do is we have to program this by putting torches on these lines to perform certain functions. Now in order to get the order correct of these functions, what we're going to do is we're just going to stack this down. So that way for our first operation we're just going to put a torch on the correct spot on this line. This is obviously going to be an inverted operation. So I hit this button, and this, what it does is it just clears the input register. So if you can consider this its own function, all it does is clear the input register, because all we've programmed it to do by setting this torch here is to clear the input register. But how do we get it to sequentially do stuff? So we're going to run this line down. What I'm going to do is I'm going to add quite a bit of delay to these lines, so that way we can see it working more betterer. Okay, so I'm going to put these delays here. And then we're going to run the same thing below. So what we're going to need to do is we're going to need to run these things down, just like so. And then when this line comes back across, it's going to be the second operation that we're going to run. And all this is going to do is going to run the same thing pretty much out to there. I think I've got this a little messed up, because this has to be one lower. So let's go ahead and just lower it one. This is good, because it lets us do extra delay in here too, so we can see it take longer to operate, but it gives me more time to explain what's going on, which is always exciting. So we have our second operation here, and we could program this to do whatever we want it to do. So we're going to have all 7 of our control lines here, and that's right, 3, 4, 5, 6, 7. Yep. Oh, whoops. 2, 3, 4, 5, 6. I think that's right. Okay, so now I can just run all of these lines up in a sequential pattern. So that way we can run the torches up, so that way we're pretty much just mirroring, or we're able to control the same lines that we were above just from below. It's pretty simple. Hopefully you understand how this works. Torches carry signal up. Got all those. We got all those. Now hopefully if we push this button down here, that line comes on. Perfect. So with our operation, you can see if we hit this button, this line turns off, and then this line down here turns off, which is good, which means this operation will happen first, and then this operation, and then we just have to stack this down as far as many operations as we need. So let's go ahead and start programming this out. So let's make sure this is the same copy A to B function that we want. So our first operation that we wanted was to clear whatever's in the A register, or whatever's in the input register, and then set it to whatever's in the A register. So on our second line down here, what we want to set it to is set the input register as the A register, which is this line, the last line down here, which is super exciting. So now I can do that, and now what you're going to see is if I hit this button, we should have a 1 set to this input register. Bam! Perfect. So we're slowly working out the same functionality that we had with our cyan line, but hopefully you can see that this is going to be way more capable than what we had before, because we could just add multiple operations here that we can control. So I'm going to go ahead and finish expanding this down and maybe a little bit out, so that way we can program some more stuff in the future. So that way we can have the same functionality that we had for the cyan line that we had at the end of episode 1. So give me just a minute and I'll expand this out. Okay guys, I'm back and I've expanded this ROM out to where it can control the entire thing. So what we have is we have 1, 2, 3, 4, 5 programmable lines that we can program to control our quote-unquote computer in whatever way we want to. And what I've done is I've very simply just wired up a very simple program, which is programmed by the torches and where they're at on the line. And this particular program, what it does is it does exactly what the cyan line did at the end of episode 1. So this will copy whatever's in register A to register B. So let's go ahead and test that out. Let's go ahead and input 3, 0, or 1, 1 into register B over here, just for test data. And then let's go ahead and leave some random value in the input. Let's say the number 2. So after this, we should see the number 1 into register B. So let's go ahead and hit this button, and if it works, I'll explain how it works. Bam. Okay, so you can see that we have the number 1 copied over here into register B. So our controller is working, which is surprising. This may or may not be the first time I'm recording this bit. So how this works is what it does is it just sequentially goes down the line and turns on whatever torches are on here in the order descending. So whatever's on top first, then second, then third, then fourth. So on this first line, we have a line that resets the input register, which is exciting. And then on the second line, over here, we have this last line, which goes all the way to allowing the control block for register A to pass into the input register. So we've cleared the input register, we've passed 1 into the input register, so now we have 1 over there. And then on the next line, line 3, you can see we follow this line all the way up. And this line, what it does is it clears out whatever's in register B to prepare whatever is the input going into there. And then on the 4th line, which I believe is the last line of this program, yes, this is the 5th, this is the 4th. On the 4th line, we have a line that takes whatever's in the input register, all the way over here, allowing this control block to allow the input register to pass into register B. So our program works correctly. So we've successfully programmed our controller to have a button that allows us to copy whatever's in register A into register B. So that's all this does. And the beauty of this, even though it's huge compared to our simple cyan line, is we can stack it. So we could put another one of these lines right next to it that has a completely different function depending on what we program in here, which is super exciting. And now, some of you guys might notice that we can compress this program quite a bit. So even though we have 5 lines of stuff, we can make this function work a lot faster by compressing some things. For example, we can clear out the B register right away, because either way we have to clear it. So we can clear it while we're doing something else, which is super exciting. So I'm going to go ahead and clear it on line 1. So we need to follow this line all the way through here. So if I clear it there, and then on line 3 I no longer need to clear it, which means I could take line 2, or line 4, excuse me, and move it up 1. So now we've just compressed our program to where instead of taking 4 steps, we only take 3 steps, and we should see exactly the same output. So let's go ahead and test it one more time just to make sure. I'm just going to input the number 3 into register B, which is exciting. And now hopefully our function works, but 25% faster, I think. You can see that the B register gets cleared out right away, and we have the number 1 into register B. So it's working, and now it's working faster. So now what we could do is we can clone this whole thing over, and we can make multiple functions, which is super exciting. So let's go ahead and grab, I need to grab all the way out to there. So let's clone this location. We need to grab all the way to there. And I believe we're going to have to come down here to copy it. Give me just a second to clone this. 1 second. Awesome. So I got it. Took me a second to figure out what I needed to do. But all I did was I just copied this line over 1. So now we have a second line that we can program. I've made sure not to copy the torches that were on there, so we have a completely blank slate that we can program to do something else. So let's make a line. Let's go ahead and label this while we're here. Let's call this A to B. And then let's go ahead and make a second function that does a similar operation, and I'm sure you can guess what it is. B to A. Okay, so we can copy most of what we got going on here. For our first line, we should also be clearing out the input register to get ready for the data to come through, and we should also be clearing out the A register to get ready for that. So for clearing out the A register, we got to follow this line right here and program that line. Cool. So now our program should clear out the A register. On the next line, we should be copying whatever's in the B register into the input register, which is going to go from that line all the way second from the last, right there. And then on the next operation, we should be copying the input register into the A register, which is going to be from this control line right here. 1, 2, 3. So now on this line, we're clearing out the registers ready for the data. On this line, we're copying the B register to the input register. And on this line, we're copying the input register to the A register. So let's go ahead and input something funky into the A register, like A3. And pass that in there. Perfect. So now we have 3 in the A register and 1 in the B register. And when we do our secondary function, which is move B to A, we should have a number 1 passed into the A register. Perfect. So now, if you've ever taken a assembly programming class, you could see that we're very quickly building an assembly language here. Very primitive, but it's working. So with this type of controller, even though it's large, we can create multiple functions that'll allow us to control our program. So that's going to be it for episode 2. I hope you enjoyed. I hope you learned something. In episode 3, we're going to be going through ALUs and what it takes to actually manipulate this data to make it do something cool, other than just moving it from A to B or B to A. So thank you for watching, and I'll see you in the next one.